Hello friends, this is AKHILESH Pandeey and we are learning the basic concept in network analysis, and in the last few lectures we had discussed about the charge, then after the current, then voltage, then power then we learned the classification of elements, then after resistance, then inductance, and the turn to read the concept related to capacitance. So this is lecture number 4 of network analysis and the chapter is basic concept. Okay, so before starting the topic capacitance, I would like to solve one question related to the inductance that we had studied in the last class. Okay, this is the question that we have. A square waveform as shown in figure is applied across 1 millihenry inductor. So there is 1 millihenry inductor, and across it this square waveform has been applied. So how much current will flow through it, and what will be the shape of the wave and the peak amplitude of the current? This has been asked in the question, and this has been taken from the previous GATE exam. This was 1987 2-mark questions. Okay, so we have 1 millihenry inductor. Okay, fine. So the relation between the voltage and current that we have studied in the last class itself, and it was V equals to L di upon dt. So if we have to find the current, then we can have this formula, E equals to 1 upon L integration V dt. Just here differentiation, so here it will be integration. So overall the current is equals to 1 upon L integration V dt. Now this is voltage in volt, and see this will be 1 volt, this will be minus 1 volt, and this is time in millisecond, and inductance value is 1 millihenry. Okay, so first of all here it is integration. So the shape of the given voltage is square wave, and its integration will be of course the triangular wave, because we know the integration of square wave will result in triangular wave. Okay, so the first point is very clear, and the first answer can be directly given as triangular. Now come to the second one that has been asked, peak amplitude. Peak amplitude means the maximum value of the current. Now come to this waveform. Here we can draw the current waveform as up to this point. Okay, fine. Integration, we all know that is the summation of individual values at individual points. So these all values will be added, and we will get the result as integration. Okay, overall up to 0.5 the voltage is positive, and then after the voltage is negative. So up to this point the current will be increasing, because its integration will be increasing. Up to this point means 0.5, this will be increasing, and then after it will start, it is negative, so negative will be added. Negative will be added means the value will start decreasing, So overall the waveform will be like this. Of course it is a triangular waveform, and the peak value will be up to this point, means up to 0.5. So if we find the area of this part, then that will be the integration value up to this point, and that will be the peak amplitude. Okay, so what will be the value of the area? So this area will be equal to what? 0.5 millisecond. It is 0.5 millisecond and into 1 volt. So this much will be the area of this part. So overall 1 by L, L means 1 by 1 millihenry, and into 0.5 millisecond into 1. So milli and milli cancelled out. Overall we get the 0.5 ampere as a result for the current. So the maximum peak amplitude will be the 0.5 ampere. So this is all about the question, and it can be solved very easily, and the basic formula that was used here is I equals to 1 upon L integration V dt, and there was some manipulation in finding the integration. Okay, so this is all about the inductance. Now I am starting the topic capacitance. So about capacitance, we all know that The property of the capacitance is to oppose the change in the voltage. We had learned the resistance, we had learned the capacitance, so inductance, and now we are learning capacitance. So property of capacitance is oppose change in voltage. Okay. About resistance, again I am discussing about resistance. The resistance opposes the flow in current. Inductance opposes the change in current. And now capacitance, it opposes the change in voltage. So whatever the voltage will be at certain point will not change suddenly. It will take some time to charge. Means if we are connecting some capacitor to some voltage source, then it will take some time to get charged. After some time it will be charged, and it will not change suddenly. Means it is opposing the change in voltage. Now the capacitor, how we can define the capacitor? So for a parallel plate capacitor, this is parallel plate, some basic capacitor. Sorry. This is the parallel plate capacitor, and the distance between the two plates is D. The surface area of the plate will be A, and if we fill some dielectric here, dielectric constant epsilon, the dielectric has been filled inside it, then the capacitance value will be given as C equals to epsilon A by D. So this will be the value of the capacitance of a parallel plate capacitor, having surface area A of the two plates, and the separation between the plates is D. Okay, so this is about capacitance. Now come to the topic that how we can relate the current and voltage in the capacitor. Okay, so we have this capacitor and this is the voltage source. So we will start charging it, and up to some point it will be charged. The capacitor will be charged with some voltage, and of course the charge will appear across it, minus here in minus side, and plus at plus side, plus Q charge will appear across it. Means overall it has been charged up to Q. Okay, so the charge will be definitely directly proportional to the voltage. As much as will be the voltage, the same will be the charge across the capacitor. Okay, so Q will be proportional to V. When we will remove the proportional sign and we will try to equate it, then we will put some proportional constant. So this will be the proportional constant CV. C is the capacitance. So if we try to find out the current, then what we will have to do? We will have to find the differential value of the charge, means the rate of flow of charge. Okay, dq upon dt will be given like this, C dv by dt. So overall we get the relation between the current and the voltage for a given capacitor is I equals to C dv upon dt. So this is the relation between current and voltage of the capacitor. Now come to the next topic related to the capacitance, and that is energy stored in the capacitor. So how much energy is stored in the capacitor? Let's see. We just derived I equals to C dv by dt, and we all know that the power equals to V into I. So we can write V as it is, and I instead of I we can write this one, and of course the work done is energy. Power is work per unit time, or you can say rate of doing work. So work done or energy will be integral value of P dt, means P we all know dw by dt, so we can write w equals to integration P dt, and so we'll put V in C dv by dt, dt cancel out, V C dv half C v square. So this is the energy stored in a capacitor having the voltage V. So if any capacitor has been charged up to voltage V and the capacitance value is C, then the energy will be half CV square. So this is the charge energy stored in a capacitor. Now come to the transient and steady state analysis of the capacitor. Transient and steady state analysis. So this is transient analysis. Transient, just we learned that capacitor, the property of the capacitor to oppose the change in voltage. So if there is a capacitor, so it will oppose the change in voltage across it, means there will be no any sudden change in voltage across it. It means if I am talking about any t equals to 0 minus, means before 0 second, if the voltage across the capacitor will be 5 volt, then for sure at t equals to 0 plus, again the voltage will be 5 volt. There will be no any sudden change in the voltage unless any impulse function has been applied. Means if any infinite function is applied across it, across the capacitor to charge it, then only it will be charged instantly. Otherwise instantly it cannot be charged. Okay, so this is the transient analysis, that for some time less than that value, minimum time, and for time greater than that value, just greater than that value, the voltage will be same across the capacitor. So there will be no any sudden change in the capacitor. Means sometimes while transient analysis we will be given the questions like this, when there is a voltage applied across it, across the capacitor, and suddenly the switch is being off, the circuit is being cut, then the voltage across the capacitor will not suddenly be discharged. It will take some time to get discharged through some path. Okay, so this is the transient analysis. Now come to the steady state analysis. At steady state, of course, the capacitor will be fully charged. The capacitor will be fully charged up to some value. Let it has been charged up to 5 volt. It has been charged up to 5 volt. Then after what will be there? Okay, so we know I equals to C dV by dt. It has been charged up to some voltage. Then after there will be no any increment in the charge, increment in the voltage. It has been charged up to some voltage. There will be no any change in the voltage further. It means dV by dt will become 0. C into 0. Of course, the current will become 0. So current becomes 0. It means there will be open circuit. Okay, so at steady state it will become open, and of course at the transient behavior the values will be same at t equals to 0 minus and t equals to 0 plus, and at steady state it will become open. And we had learned about the inductance as well, that inductance at steady state will become short circuit. So we must learn these two, and this will be very useful in the coming chapters. So at steady state the capacitor will behave like open circuit because it has been charged up to some voltage, and then after there is no any change in charge and change in the voltage. So dV by dt will become 0, and so the current through it will be 0. It means that will be the open circuit. And for the similar case we had defined in the earlier class, that the inductor will behave like short circuit at steady state. So at a steady state capacitor is open circuit, at a steady state inductor will be short circuit. So that's all about the transient and steady state analysis of capacitor. Now the last topic of the capacitor is related to its connection, and not similar to the resistance and inductance. Its connection will be quite different from that. And for series connection, if you will say for series connection, C1, C2, I am not going into the derivation, I am just giving you the result. So overall the equivalent capacitance of these two capacitors will be 1 upon C1 plus 1 upon C2, and if we connect two capacitors in parallel, then the overall capacitance value will be the summation of the two, that is C equivalent equals to C1 plus C2. So this is the parallel connection and this is the series connection. So that's all about the capacitance topic. and which is important for GATE exam point of view. So this is all from this lecture. Thank you so much.